Okay, we're gonna take a step back now and just kind of review a few things about graphing and solutions. And we're gonna start by sketching the graph of the following quadratics. So let's start with the first one, f of x equals x plus 3 all squared minus 1. And don't forget, you're copying what I'm writing on your worksheet. So you should have gotten a worksheet from the sub, the guest teacher, and you are copying what I'm writing. So if we take a look at this first one, the vertex is -3, -1, right? If you just remember vertex form, a times x minus h all squared plus k, and our vertex is our h and our k. So -3, -1, I'm going to make my vertex, and then I'm going to use my a value to do the slope to make the next 2 points. So if my a value in this one is 1, that means I'm going to use a rise over run to get my first point, and then I'm going to make a dot symmetrical on the other side of the vertex. Okay, and then so I know this is opening up, and I'm going to just sketch a parabola, a U that goes through these points as best as I can, and go all the way across my grid and put arrows on both ends. Okay, so what do we notice about this parabola, this graph, is we notice that there are 2 x-intercepts. Right, so we can see that there are 2 x-intercepts. We also know that that's called the solution or the zeros or the roots. So there's 2 of them for that one. Now let's take a look at the second one, right? Remember, our vertex form is a times x minus h all squared plus k. So the thing that's changed in this one is actually our k. So now our vertex is at -3, +1. -3, +1. And my a hasn't changed. So my a is still 1 over 1. So up 1 over 1, make a dot symmetrical. And remember, you can always pause this video if you need a minute to kind of catch up with your copying. I'm going to sketch my parabola. And so I bet you can already tell what we're going to write here in terms of the number of solutions. In this case, our parabola is opening up, our vertex is above the x-axis. So in this case, there are no x-intercepts or solutions. Okay. So just a quick review, when you're looking at quadratics, there's 3 possibilities that exist. So those 3 possibilities are at the bottom of your worksheet. So we could have, let me clear my drawings. So we could have a situation like the first one we drew, where we have 2 solutions, right? 2 places where it crosses the x-axis. Another situation we could have is we could have 1 solution, which means our vertex is our x-intercept. And then the last situation that we could have is we could have 0 solutions. So I know we've already gone over this. That was just a quick review. What I want to talk a little bit more about is how can we tell without graphing, using our vertex form, if we have 2, 1, or none, because sometimes we just need to know how many solutions are there. So if you guys will turn over to the back of the first page of your packet, we're going to continue our exploration there. So maybe take a minute if you want to pause the video and look at these. And basically, the key to what we're doing today to decide if we have 2, no, or 1 solution is by looking at our a and our k values. So what I'd like you to do is just take a minute, this first part of our table, that is where we have two solutions. This one is where we have no solutions. And then this final one is where we have one solution. So think about your A's and your K's. See if you can come up with a rule, or if there's something that you see that maybe would help us to just figure out if there's one, two, no, or one. Okay, and you can pause it and then turn it back on when you're ready. But one of the things we're going to ask you is, what do you notice about the A and the K in the first one? And what we want you to see is that when you have two solutions, one of your values, your A or your K, is positive, and one of them is negative. Okay, one's positive and one's negative. So that means when you multiply your A times your K, you end up with a negative answer. That's what happens when we have two solutions. So now maybe you can think about no solutions. What you should notice there is that both values are either positive or negative. Okay, both values are either positive or negative. So in that case, when you multiply your A times your K, you're going to end up with a positive answer. Okay, and then in the last one, we see that our A is positive or negative, but our K is 0. So I'll just put that up here. We don't have a space for that, but our K up here is 0. So we can develop a rule, something to make it really easy for us. If the question is how many solutions, instead of having to graph it and look at the graph and see, we can quickly decide how many solutions by looking at vertex form. So here we go. If A times K is negative, then we're going to have two solutions. If A times K is a positive, we could say maybe positive number, positive product, we're going to have 0 solutions. Let's just add number here. That'll make it a little bit more complete. And if A times K is 0, there will be 1 solution. So this might be a little bit confusing at first because you have a positive number, 0 solutions, but if you get 0 for your answer, there's 1 solution. So you might need to take a little bit of time to think about this. And on your note sheet, we gave you a summarizer that shows you basically what this concept, a summary of this concept. Now, this is another place where algebra is a new language, so you may want to take a little bit of time to memorize this. All right, so let's take a look at the bottom of this page. So let's see here. Let me clear my drawings again. Is this the right one? Yeah. Okay. So the question says, determine the number of solutions to each quadratic function. If there are solutions, determine what those solutions are. Okay. So in this first one, we have to change it to vertex form before we can figure this out. So we need to change it into vertex form. So this is a nice little trip down memory lane. All right, so we're gonna have to make our box. We need our perfect square, right? So we take this first part, do our perfect square, x, and then we have -5. So there's my perfect square. So the inside is x squared minus 5x plus 25, but it should be plus 40. So I need to add 15, right? K equals C, so it should be 40. So now vertex form is y equals x minus 5 all squared plus 15. Okay, so now to find how many solutions I have, I take my A times my K, A times K. So I have 1 times 15, which is a positive 15. And if you look right above these on your worksheet, a positive product means I have no solution, right? This one's positive, so it's positive. Okay, everybody good? All right, look at how we are just combining everything we've learned. So let's take a look at this next one. It's already in vertex form, so I don't have to do any moving around. I'm going to start with this A times K. So I'm going to do A times K to find out how many solutions. So A is a 1, K is -4. 1 times -4 is -4. If you look right above this activity, negative product means I have 2 solutions. So how can I solve this? An easy way to do this, that's right, you people. So I have x plus 3 all squared minus 4. I can easily get the squared part alone by adding 4 to each side. Well, I guess probably what I should have done, everybody, I should have set this equal to 0 first when we solve. So we're going to set it equal to 0 first, and then we're going to add 4. So we have 4 equals x plus 3 all squared. So my squared term is alone. I'm going to square root this side, square root that side. So positive or -2 equals x plus 3. And I know this looks a little bit different than how we did it because it's on the other side, but it doesn't matter. We can still solve it. -2 equals x plus 3. And we subtract. So one solution is -1. And -5 is the other solution. So I know I had a little bit more room than you did. You might have had to squish this in a little bit, or maybe right underneath it. But the 2 solutions are -5 and -1. Okay, finally, the last one, we have an equation written in standard form. So I am going to have to turn it into vertex form in order to do this. So I'm going to make my box. And I have x, remember we're going to do the perfect square for this part, plus 1, x plus 1, and we have x squared plus x plus x plus 1. So we have y equals, oh, it should be 1, and it is 1, right? K and C, it's already 1, so I don't need to add anything. So we can just say that y equals x plus 1 all squared. Now, I know that my A is 1. So let me do my A times my K. I'm going to do it up here. because I just want to save space. So my A is a 1, my K is a 0. So I end up with a 0 product. And when I look up above this, I see if I get a 0 product, I'm looking for 1 solution. So let's solve this. Step 1, set it equal to 0. Step 2, do the square root. So 0 equals x plus 1. So now there's only one thing I can do. There's not two. 0 only has 1 square root. Square root of 0 is 0. So we're going to just subtract 1, which means that my 1 solution is x equals -1. So you are going to do some practice, then you'll do your homework. And finally, if you have extra time, there's some enrichment, but you should do your homework before you do the extra practice. So you're going to work on this nice review of a lot of the different skills we've been working on. And we will definitely go over it when I see you next.